All right, welcome to N9.3, square roots. So square roots is not a real difficult concept. The most important issue with square roots is that people think that this means 5 times 2, and that is not what it means. This means 5 squared. The little 2 tells you how many times you're going to use your base. So it means 5 times 5 because we're using it twice. So keep that little tidbit in mind and you will be fine with square roots. So let's have a look at the indicators real quick. Looking at what type of number results from squaring of a rational number. Determine some strategies to decide if a rational number is a perfect square. So if you actually took the square root of that number, you would get a whole number, like the root of 25 would be 5. Determine the rational number for which a given rational number is its square root. So 4/3 is the square root of what rational number? So if you took 4/3 and multiplied it by itself, you're going to get 16/9. Okay. Apply strategies involving benchmarks, and I have a little activity coming up for that. So estimating the square root of a rational number that is not a perfect square, such as the square root of 45. You're not going to get a whole number. So we'll have a look at that in a minute. Determine, using a calculator, the approximate value of the square root of a rational number that is not a perfect square. That's pretty easy. Punch in the numbers. Boom. Explain why the value shown by technology is only an approximation. So we just talked about rational numbers, and sometimes those irrational numbers have repeating or non-repeating decimals. And so if you have a rational number that has a repeating decimal, it's still an approximation because you have to cut it off at some point. Determine a strategy, if applied to writing a decimal, would result in an irrational number. So you could have a number like this. Oops, where's my mouse? There we go. This number just keeps on going and going and going. You can tell by the ... at the end. Determine a rational number whose square root would be between two given rational numbers. So I've got that activity coming right up. Let's have a look. Okay, some weird and wacky ways to write rational numbers. Do not be freaked out that there is a fraction inside this radical sign. You're just taking the square root of 4 and the square root of 9, which is 2/3. No biggie. Because the negative sign is outside the radical sign, you apply that in the end to the answer. So they're saying the root of 25 is 5 and the root of 81 is 9, but the whole thing is negative. Okay, again, do not be freaked out by all these little marks and numbers. Just do one step at a time. Inside the brackets, you see that negative 2/3 is getting divided by 2. Divided by 2, which is the same as 2/1. And we learned in our fraction unit that you keep the first fraction, you change the sign, and then you flip it. Okay. Negative 2 times 1 is negative 2. 3 times 2, 6. Okay, now going back to the top, we're going to square that. So squared. Okay. So you can see these steps that I just showed you, that's what they're doing right there. Negative 2/3, they flipped the 2 and multiplied, and then they squared it. So right now we're at negative 2/6 squared. Before they even squared it, they reduced 2/6 down to 1/3, and then squared those guys, and you end up with 1/9. Cool beans. Okay. Finding a rational number whose square root is between those two fractions. 1/3, you can see 1/3 is right here. And 1/2. So a rational number, some number that we don't know, has a square root that's going to land somewhere in here. Okay, from here to there. Okay, well, what number gave us the square root of 1/3? If I squared 1/3, it's 1/9. So 1/9 is down here somewhere, approximately. And what number would have a square root of 1/2? Well, again, if we squared 1/2, it would tell us which number has the square root of 1/2, and that's 1/4. And 1/4 is right here. So it says find a rational number whose square root is between those two. So pretty much any number in between 1/4 and 1/9 would give you a square root between our target. And if you wanted to find out more, you could say, well, it's hard to compare 1/4 to 1/9 because they don't have like bottoms. So you can turn this into a common denominator and say, I'm going to multiply by 9/36, and I'm going to multiply this by 4/36. So if I took this number line, let me just change colors. If I took this number line from 0 to 1, and I chopped it into 36 bits, make a smaller pen. Approximately. And we'd be going from 4/36, right about here, to 9/36, right about here. So anything in between there. And you can see that matches up with the zone that I had marked out there. Okay, so now we're going to find the square root of 45. We're just going to approximate. This is just a guess, not exactly. Without a calculator. So I've already given you the answer. It's approximately 6.7. And you're probably wondering, how did I get that? Well, here's 45, right? The square root of it is going to give you a number between 6 and 7 because the square root of 36 is 6. And the square root of 49 is 7. So between these two whole numbers, our answer will be. Because if we squared 6.1, 6.2, 6.3, 4, 5, 6, etc., we would get all these numbers in between, right? So I can tell by my number line that my halfway point is somewhere around here. And so this should be 6.5, right? So if I'm looking for the square root of 45, I would venture to guess that it is bigger than 6.5. So you could do guess and check. And so I'm just going to miraculously guess 6.7 because I'm magical like that. I'm going to square 6.7. Okay. So if we said, well, this looks like 6.6, this looks like 6.7, 6.8, 6.9, and 7, right? So 6.7 looks like it should line up with 45, so let's have a look. 7 times 7 is 49. 6 times 7 is 42. Add your 4. Put a 0. Done with that guy. 6 times 7, 42. There's my 4 up there. 6 times 6, 36 plus 4 is 40. Add them up. Now, 44.89 is pretty close to 45. So if we took the square root of 44.89, that would give us 6.7. If we took the square root of 45, if I just type it on a calculator right now, it's 6.708203933. It's perhaps an irrational number that the decimal doesn't end. So, all right, there you go.